Now we are going to describe how we can get rotational motion. You know the different equation of the rotational motion. Any object is in the motion and which is in the rotation. You know the which is revolving, which is moving in a circular path, which is moving in a curve. At this way, how can we get the some equation so that this equation can describe the motion of any particles. Here is some of the equation you can see here. Equation 1 I have written here. This describes the angular displacement, and this is angular velocity equation. This you can see here. This one is angular acceleration equation. The angular acceleration you can get in this way. By using this equation you can solve any problem related to angular motion. In this way, how can we get angular displacement, how any object displaces by making an angle, how much object has angular velocity we can know from this, how much any object which is in a rotational motion has velocity, here angular acceleration alpha, we can calculate this. Here you can see here. First of all, I have written this here in a what you can see here on a figure. Exactly you can see here at in the figure one of this structure you can see the rigid body. Here I have written what is rigid body. Here those body whose shape and size cannot be changed. This body we cannot change its shape and size by applying some external force, which we call rigid body. The rigid body is the body whose shape and size cannot be changed. You can see there one of rigid body, and this rigid body can undergo translational as well as rotational motion. It not only goes in a straight line, but it also goes in a circular path too. You can see here at. If suppose this rigid body, this you can see hold the body is at a point at 0 time t. After some time, when it is in a rotation, reaches at B covering the arc S. You can see S is an arc and it has a radius R from its center, where we are revolving, we are rotating that object. You can see here a center, and this is the radius. And at that time, when object reaches at point B from A, it has an angle, suppose theta, you can see. And the same what we see here on a figure, I have written here, don't be confused here. If theta be the angle of a displacement, this angle of a displacement, and R be the radius, you can see the radius, and S be the arc, then the angular displacement is written as here theta equal to S by R. The arc divided by radius is a angular displacement. When we take angle in account, how the object displaces from A to B, it can take that into the account, so that theta equal to S by R. This displacement, here I have written angular displacement because object is rotating by making an angle theta, so that I have written this. And again you can see if omega be the angular velocity, and how much angular velocity that object has, which is that rigid body which is revolving here, which is that angular velocity means it is the rate of change of angular displacement. That means per unit time how much change in angular displacement, which we call omega equal to du theta divided by dt. You can see here derivative of theta with respect to the time, d theta by dt. And theta equal to S by R, you can see here S by R I have written in the place of theta, and all this d by dt as same as here at, you can see. And 1 by R is a constant, so we can take it out of this derivative, and because the derivative doesn't work for the constant term, it does work only for variable part. So 1 by R ds by dt equal to equation, this is equation 1, which is the angular velocity. That means per unit time how much angular displacement is changing. This gives some knowledge about this. And this Also this one angular velocity also changes with the time. How it changes? This is taken into account by the help of the angular acceleration, which is change of this quantity per unit time. Here the rate of a change of an angular velocity. This is the change in angular velocity per unit time. You can see alpha is angular acceleration, which is per unit d omega by dt equal to d by dt. You can see here in the place of omega 1 by r ds by dt, because we have written here omega equal to 1 by r ds by dt. Exact same I have written in the place of this omega 1 by r ds by dt. 1 by r is common, so I take 1 by r square, and d square you can see dt square. This way we have written here equation 3, which is for the angular acceleration. So all this what we are going to know is here how the any object when is in a rotational motion, it has an angular displacement, how it got displaced. Here we can get with the help of this one, and how much that object has angular velocity in per unit time, how the angular displacement is going on, we can get with the help of this one. How this velocity is also changing with the time, we can get with the help of this angular acceleration by using alpha. So that all three equations help you to describe the motion of this rigid body which is in this rotation. And second term, the second part of it is we are going to compare this rotational motion with linear motion. In next portion we discuss about the translational motion of that rigid body. Here we describe rotational motion. Next one we describe about translational, that means when this object also is in what translational motion, how the motion is described related to it, we will discuss in the next part. Thank you.